Okay, let's get straight into this. What do we use Pascal's Triangle for? Okay, so we've been looking at Pascal's Triangle. And remember, each row starts and ends with the number 1. The top row is actually called row number 0. Right? And the other rows make a little bit more sense because, like, if you look at row 6, it starts with 1 and then there's a 6. Or if you look at row 8, there's a 1 and then an 8. And of course, there's an addition pattern that we've talked about, how those internal numbers come. And so how do we use this to find the product of polynomials? Well, we had this question on the first day of this unit, and I multiplied it out the long way, showing step-by-step work, and finally got an answer of x to the 4th plus 4x cubed plus 6x squared plus 4x plus 1. Notice if I look at row 4 of Pascal's triangle, right, the 4th power says look at row 4, and I see 1, 4, 6, 4, 1. Look at the coefficients on the answer, 1, 4, 6, 4, 1. Right, 1x to the 4th, 4x cubed, 6x squared, 4x plus 1. So if I wanted x plus 1 to the 6th power, I say, hey, the exponent's a 6. I want to look at row 6. And I see that 1, 6, 15, 20, 15, 6, 1. So I'm going to have 1x to the 6th, 6x to the 5th, 15x to the 4th, 20x to the 3rd, 15x squared, plus 6x plus 1. And of course, this is easy because it's x plus 1 inside the exponents. And you're probably thinking, well, what if there's a number that's not 1 inside the exponents? This one was also from the very first day, and of course I've got on a poster up in the wall in the classroom. And we've multiplied it out the long way, and we ended up with x to the 3rd plus 15x squared plus 75x plus 125. So the exponent's a 3. You know we're going to look at row number 3. And row number 3, of course, has that 1, 3, 3, 1. So how can we use this? Well, I'm going to use that 1, 3, 3, 1. And of course, I'm going to have x to the 3rd, and then x squared, x to the 1st. So I don't really need to write down that 1. X to the 0, which of course is going to just be 1. And then see the plus 5 inside the parentheses? That runs the opposite direction. I'll end with 5 to the 3rd, and then there'll be a 5 to the 2nd, and then 5 to the 1st, and then 5 to the 0. And then if I multiply these out, of course, remember that anytime I've got something to the 0 power, just the number 1, and if the exponent's 1, I don't really need to write it. I go, oh, look at that. I've got 1x to the 3rd, and then I've got 3 times 5 with the x squared, and then I've got 3 times 5 squared with the x, and then I've got 1 times 5 to the 3rd with for that 125. So again, I'm thinking, hey, if the exponent's a 3, that means 3rd power. I'm going to look at row 3. I'll need that 1, 3, 3, 1. From the left, I'll need x to the 3rd, x to the 2nd, x to the 1st, x to the 0. The negative 4 will run the opposite direction. Negative 4 to the 3rd, negative 4 squared, negative 4 to the 1st, negative 4 to the 0. Of course, anytime the exponent is 0, we're looking at the number 1. Negative 4 to the 1st is negative 4. Negative 4 squared becomes a positive 16. Negative 4 to the 3rd is negative 64. So 1 times 1, of course, leaves me with 1. 3 times 4 is 12, but of course it's a negative 12. 3 times 16 is 48. 1 times 64 is 64, but of course it's a negative 64. And so there's the answer. X to the third minus 12x squared plus 48x minus 64. And of course, if I write it tidier, that's what it should look like. Now, can I do this without showing any work at all? Well, it's a fourth power. I know I'm going to look at row 4. So I'm going to need 1x to the fourth. I'll need 4 times 2, which is 8, with my x to the third. I'll need 6 times 2 squared, which is 24, with my x squared. I'll need 4 times 2 to the third. 4 times 8 is 32, with my x. And then I'll need 1 times 2 to the fourth. 2 to the fourth, of course, is 16. There's my answer. Again, can I do this with showing 0 work? Well, I know I'm going to have 1x to the third. I'll need 3 times negative 7. That makes negative 21 with my x squared. I'll then need 3 times negative 7 squared. Well, negative 7 times negative 7 is 49. 49 times 3 is 147. Of course, you can use a calculator if you can't do this in your head. And then I need 1 times negative 3 cubed. Well, negative times negative times negative comes out negative. 7 to the third power, 343. There's the answer. Again, I know I'm going to start with 1x to the third. Then I'll need to do 3 times negative 3. Then I'll need to do 3 times negative 3 squared. And then I'll need 1 times negative 3 to the third. Notice that when there's a negative inside the parentheses, we alternate positive, negative, positive, negative. And so it looks like it's TTT. Time to practice.